Yeah. Okay.
Cool. So to get started, we're going to talk about the difference between a class and an object. And we're just going to make sure that we have a solid understanding of it. Ashley, if we can move on to the next slide. Thank you. So a class is, simply put, it's just the abstract idea of something. So if I had a vehicle class, the key is to make it as unspecific as possible. You want it to be as malleable as possible so that when we make specific objects, they can be personalized. Does that make sense?
It's like the generic traits of it, you mean? That like span the entire kind of, I don't know, object that we're talking about, I guess.
Absolutely, yes. So if I had a house class, I would of course want to include the normal things I'd find in a house, but I wouldn't make it like specific. So my house class would maybe include a roof. Exactly, a roof. It maybe include some doors, but I wouldn't specify things like, here's the color of the roof. I wouldn't specify things like, here's how many doors it should have, because different houses are going to have different numbers of those things. They're going to look different in those things. And that's when we come into this idea of an instance. So an instance is a specific object that we created from that class. So an instance would be a specific house where now I get to say, this is how many roofs. We're only going to have one roof, but let's say it's a futuristic house. He has multiple roofs for some reason. This is how many doors. Exactly. This house has 3 bathrooms, so on and so forth. Next slide, please.
I just want to say one thing real quick before we move on. Is that okay, Praise?
Yeah, absolutely.
Yeah, so
Please.
I know someone mentioned earlier, like inheritance and stuff like that. The way I think about in terms of relationships between classes, objects, subclasses, parent classes, is a class is going to be like your category, right? So your category could be like, let's say your category is cats, right? Your object in this case would be a specific cat, like for example, like my cat Ace, who is standing right there staring at me. Okay, or like someone else's cat. That's gonna be your object, which is like a specific, like one specific cat. Meanwhile, the class, the cat class is going to be your overall like category. But let's say you have a category, but you want to make it more specific, and you have like a subcategory. For example, like we have like overall cats, and then underneath cats we have house cats, right? So in this case, cats would be your parent class, and then house cats is going to inherit from your cats class. And then, my cat Ace would then just be an instance of that subclass house cats. Does that make sense, everyone? Okay, sorry, Praise, you can move on.
No, please. Actually, to go off what Ash just said, can anyone think of what would be an appropriate subclass for our make-believe house class? What would be a good one to inherit from our house class?
Like a condo or something, maybe.
A
Yeah.
condo?
Yeah, like a multi-story or a single story or something.
Yeah, absolutely. Wonderful. Okay, so here's another fake class, our person class. You see, it's an outline of a person because it's just the blueprint. Nothing specific has been laid down. So what might be in the init of this person class when I'm setting it up? Init, it's our constructor. It's just those things like the door, the roof. We're not specifying anything. We're just making it known that this is an option here. So what might be in the init of our person class?
Like a name, age, height, weight, maybe.
Yeah, absolutely. Anything else?
Pronouns.
Pronouns, absolutely, yeah. Next slide, please. So this is that idea of instances of specific objects. So Sally's a person and she's an instance of the person class. So is August, an instance of the person class. They're objects and they're created based off of the person class. Does that make sense so far? Any questions about any of that? Perfect. Next slide, please. So let's talk about this idea of instance variables. So you see here, we have something like age. Well, what's an instance variable first? An instance variable is just a variable that's associated with a class, that's associated with that's associated with a specific instance of a class. So for instance, Sally, of course, has a different name than August, right? And therefore the name is an instance variable because it changes, it's completely independent, no matter, like, I explained that horribly, I apologize. So let's take age for an example. Age can be an instance variable of a person object because Sally and August can have different ages, right? So even though the age variable can be the same value, they're also completely independent. So let's say Sally has a birthday and her age increases. That doesn't affect August's age variable. Does that make sense? Can anyone give me another example of something that's not already here that might be an instance variable?
Well, I was going to add on that the instance variables, it doesn't necessarily have to be a string. So the examples here, name, age, job, you can think of them as being strings, but they can also be arrays. So if you want your person to, have items inside of the array, that can also be an instance variable as well.
Like, for example, like what Juan is saying, like, let's say if you have a class student, right? One of their instance variables could be their backpack, which could contain the names of all the different objects in their backpack, something like that. I think that would also work.
Absolutely. So it's those things that are going to differ from instance to instance. So different houses are going to have different numbers of bathrooms, different numbers of doors, things like that. They're not dependent on each other, even though they exist for all of them. Next slide, please. And then there is a class variable. These are variables that are shared by the entire class. These are not independent. If I change it, it's going to change for the entire class. So most people hopefully only have one head, or well, I guess you can have more than one head, but most people are going to have one head and one brain. Hopefully you don't have 0 heads. But if I were to change that for this class, it would be changed for everybody. Does that make sense? I guess head is a bad example, but brain maybe. If I were to change the number of brains here, everybody would end up with a different number of brains. Does that make sense? Okay.
Yes.
Wonderful. So changing a class variable affects every instance of the class. And one thing that wasn't mentioned here is because it's not assigned to a specific instance, I don't need to call an instance in order to access this variable. So I can just do person.head to find out the number of heads. Does that make sense? Whereas like for Sally to find out her age, I would need to call on Sally's instance and then say Sally.age or something like that. Does that make sense? Perfect. Well, I believe this is the last slide. I think we can get into working through some examples now.
I kind of have a question on that. So like in this example, everyone only has one head and one brain, but I mean, so you wouldn't really, like, when would you even need to call that? Because you kind of already know the answer to person.brain. It's going to be 1, obviously, right?
Yeah.
So what's like an example or a situation where a class variable, I mean, where you'd actually need to call it to like find out the information? Because if it's always the same for everybody, it's like, you kind of already know the answer to the question you're asking, I guess.
Perhaps it might be useful for your end user. So let's say I'm an alien and I don't know much about people and I want to find out the number of heads they have. That's a really impractical example, but I want to find out about that. And let's say I had another subclass. I could assign them a different number of heads, right? So it might be useful to ask, okay, how many heads does this particular class of people have? How many heads do they have? So it might be useful, but it very much depends case by case. I don't know if someone else has something to add.
Yeah, I have an example I can think of. Mark, were you in the breakout room yesterday for the?
Yeah.
Me?
So remember the Pac-Man example, like Reno?
No, I
and
wasn't in the breakout room, sorry.
What?
I wasn't in the breakout room.
No, I was talking to Mark.
Oh, okay.
Sorry, Juan. So wait, Mark, you weren't in there, right? Just give me a thumbs up. Yeah. So remember the Pac-Man example? So like for example, like let's say we look at our like our board class, right? Or our game class, right? An example of a class variable we could have there would be, for example, like the dimensions of the board, right? Like we can change around the walls and stuff. We can change around the colors of the ghosts, Pac-Man, the rules and stuff. But whenever we make a board, we're gonna have every single board be the same size, right? But let's say, we want a way to update the size of the board, right? So this way, instead of using, a 23 by 23 board inside of our code, we can use a class variable, right? So in that case, all we have to do is update the class variable, and that automatically changes all. Well, let's say we make a game with like 100 different levels, right? Instead of going through and manually updating each level like 100 times, all we gotta do is change the class variable from like that 13 by from that 23 by 23 to like a 30 by 30, right? And suddenly all of our boards are now going to change to being 30 by 30. Does that make sense? Because it's shared across every single instance of that board class. And if we made like 100 levels with 100 different boards, even though they're all the same size and they're all different, we want to increase the size. That's like an easy way to do it.
Yeah, that makes the use case a little clearer for me.
Yeah, you get it. It's when you want to have something that you can update across all your instances of the class at once. Generally, usually it's pretty niche using a class variable. Most of the time you can get away with using mostly just instance variables, but sometimes having a class variable in certain scenarios will make your life a lot easier. But I wouldn't say it's 100% necessary to always have them, because it also creates like issues. For example, like let's say like one of your levels would break if the board size was increased, right? But you would know that, but then you increase the board size and all of them work, but that one that you didn't account that for breaks, right? So in that case, it didn't really work as well as we wanted. But usually, as long as you keep that in mind that you have a class variable, you can work around that, and it's generally fine. Hope I didn't confuse anyone with that explanation.
Yeah, sorry. That's all right. No, I said this might actually be a dumb question, but is that why you don't use self for the class variables, because it applies to everything inside that class, but you use self for the instance variables because they're specific to the specific instances that they're applying to?
Exactly. Self. So you know how like when let's say
That
you
makes
want to
sense.
get like August's name in the last like example, like with the people, if you go like back here, right? Like Sally and August. So in this case, we would do like August.name, right? But we don't know the actual name of the class. So the keyword in Python we use is just self. Yeah, and then self basically will just replace itself with whatever variable that we named our instance, essentially.
Yep, and it doesn't necessarily have to be self, it's just how the convention works. Other languages like Java use this instead of self. Yeah, just a fun fact. And we'll cover class variable and class methods in our example too. So, yeah.
Are there any other questions? Anything? Okay, if not, then I think Juan and I can just get into that example for you guys. Juan, if you want to share your screen.
All right, can everyone see the Pokemon? All right, so this is our problem statement. Welcome to the world of Pokemon, where Pokemon trainers battle each other with their Pokemon creatures. For simplicity, each trainer will hold only one Pokemon, And Ash right here is a new and promising Pokemon trainer, and help him add
It's not
Pikachu
me, it's him.
to his part. Yeah, it's just a coincidence that one of our TA interns are named Ash. Yeah, help him add Pikachu to Ash's party and battle the formidable gym leader Brock. Okay, so anyone a Pokemon fan by the
Yeah,
way?
for simplicity's sake, I think we're gonna keep it with Gen 1.
Yeah. Okay, so directions. Here, I'm gonna put this to the right and then put the code to the left so you can see both.
Yep, is that good for everyone?
Yeah, can everyone read everything?
Yeah.
Okay, so first it says define a Pokemon class. So I'm gonna define a Pokemon class. And then it says think of the instance variables or nouns. Oh yeah, I forgot to mention this, but you can think of instance variables as being mostly nouns, and then methods as being mostly verbs. So methods would be actions, and instance variables would be like properties.
Yeah, so if we go back to like the human example from before, right? Your instance variables are like your name, your age, stuff like that. Your methods, your functions are going to be like things like run, speak, jog, stuff like that.
Yep, exactly. So
Go.
yeah, go ahead.
One of your methods could be go, because Pokemon Go.
Oh, nice.
Okay, so yeah, let's think of the instance variables or nouns this class will have. So let's define the init method and put all the instance variables inside of the init method.
Oh
Okay,
boy.
so what is one attribute then that a Pokemon could have?
How simple or complicated do we want to get?
Very
Try to keep
simple,
it
very
like
basic.
kind of simple for now. Right now, because if you look back to the problem, we're just gonna, for simplicity's sake, we're gonna, like the Pokemon's only gonna have one attack, and we're just gonna have 2 Pokemon and 1 for each trainer.
Oh, okay. Let's go with name.
Name, that's a very good one.
Very important.
Okay.
What about type?
Oh
Yeah,
boy.
no, we'll
Are we-
pass in.
Are we
yeah,
are we
what were you
limiting
gonna
it just one type for now?
say? Yeah, one
Maybe
type
for
for now.
simplicity,
Okay.
like just say like, I know a lot of them have two.
Well, even 3 nowadays.
Is
Yeah.
it really three now? I remember two.
No, yeah, I think Gen 5 has some of the 3 types.
All right. Anyway, we'll just pass in the name as a parameter when we initialize the Pokemon class. All right.
What other instance
And,
variables can you guys think of?
Pokemon needs to be able to attack one another. So what
Ability.
values? would
Oh, wait,
we
wait.
need?
No, wait. Would that be considered a method?
Moves?
Yeah, moves could be one.
But let's think about it. We're
I
only
was
having the
thinking more
Pokemon.
along the lines of like, yeah, go ahead, Ash.
Yeah, sorry, I was gonna say like what's
Yeah.
each Pokemon is gonna have. We're gonna, for simplicity's sake, we're gonna give each Pokemon 1 move. Okay. So if they all have 1 move,
That would be class, wouldn't
do
it?
we need maybe instance variable? Like is there like a differing amount of moves between the Pokemon?
Some can share the same move.
No, I'm saying in this case, like if we say like amount of moves, what's our instance variable, right? So we said each Pokemon is going to have how many moves? 1, right? So if each Pokemon has like the same amount, is there any point to making it an instance variable? Right? Because if you think about it, instance variables are supposed to differ between different instances, right? And if it's all the same, and if it's not differing, then we can just use that as a class variable, or just like hard code it in and not even include it at all.
Yeah, so yeah. I was thinking more along the lines of for the instance variables like health and then the damage value to keep it simple. So when you instantiate the Pokemon class, you'll pass in the health that the Pokemon will have and their damage value. So it looks like this. And I think that's like the bare minimum that you need for the instance variables of the Pokemon. And then part B says, think of the methods or verbs this class will have. Well, we need a action for one Pokemon to attack another. So I think we can aptly name that attack. And you can pass in parameters like other Pokemon objects inside of the attack method parameter. So you can do like Pokemon. And how would one Pokemon attack another Pokemon? How would that work using these instance variables?
Does anyone have any ideas?
You could somehow incorporate health or doing like a logic where health minus damage is like the value of the attack.
Who's health and who's damage?
I would say the faux Pokemon. Well, I would say health is the faux Pokemon and damage is self, possibly. I'm just kind of spitballing.
Yeah, no, that's exactly right.
Yeah,
No, it makes sense, right?
Yeah,
If we're attacking, then the damage is going to be coming from us, and what we're attacking, that's where the health's going to come from, right?
yeah. So right here, you're calling faux Pokemon's health attribute instance variable, and then you're subtracting the current Pokemon's the current Pokemon's damage from the faux Pokemon's health, and that's how the attack would go. Yeah, it's exactly as Alex said. So, I think we need like logic to check if a Pokemon is dead or fainted. So,
Okay, so let's first think, do we need any other I'm blanking. What's the
Experience
about-
level up.
do we need any other parameters? That's the parameter. Do we need any other parameters for this function for
You could
check if fainted besides like ourself?
Wouldn't you want that to be a class method?
If it was a class method, it would be checking if every Pokemon was fainted, but you're checking if this
No, I
particular
mean-
Pokemon is fainted.
I mean, pass in a Pokemon to it.
Oh yeah, you can do it that way, but we're already passing in a self. So this
we
is
can
like the
basically check
instance.
if ourself is fainted, or you could make it a class method and pass in a specific Pokemon. This way it's kind of something that applies to the object itself, so it can check itself to see if it's fainted or not.
So would you want it as a Boolean value then? So like self dot check if faint, you would want it true and then for now and then have a logic to check its health. And if it's lower than say 0, then change that Boolean to false or you know what I'm trying to go at.
No,
So
yeah,
basically-
exactly. No, yeah, that's exactly right.
Yeah,
Exactly right, Alex.
yeah. Well, I'm gonna just quickly code what Sarah's idea was, and then we'll actually do this one. So you can make it a class method, and then you would pass in a Pokemon to this, and then you would actually call things like Pokemon that health, and if that's, you know, if this is lower than or equal to 0, return true. That's how you implement a class method like this. Oh wait, this one needs to be CLS. But we're just passing in self, so we'll go with this option. But yeah, that's how you would do using class method. All right, so what Alex was saying, create like a Boolean value to check if it's fainted. Yeah, that sounds like a great idea. So is fainted. Let's just set it to false for now. And then let's check the self's Pokemon's health and see if it's less than or equal to 0. And then if it's less than or equal to 0, that means it doesn't have any health left, which means it's fainted. So we're going to check if self.health is less than or equal to 0. And if this condition is true, then we're gonna set is fainted to true. And then else, now this else loop is basically if self.health is positive, so they still have health remaining, which means they did not faint yet. So is fainted would be false in this case. And then finally, we can return is fainted so that we can access the is fainted value outside of this function. All right. I think that's all the methods this class will have. So part B is done. Part C, we want to print out the entire Pokedex. And for those of you that don't know, it's just a list of all the Pokemon creatures that exist in the universe. So how can we implement this using class variables and class methods?
Can anyone think of
Any
how
ideas?
we would go about doing this?
Does it matter about a certain order? Do we want to add ID numbers?
Yeah,
Well,
we can
think about doing
definitely
it
do
with what we
that.
have right now.
Yeah, I was just thinking just having the names to keep it simple.
Yeah, we don't need like the actual.
But yeah,
name.
definitely you can have IDs and things like that. But yeah, so we're going to use class variables and class methods because the entire Pokedex, it doesn't belong to a particular Pokemon instance. It belongs to the class Pokemon as a whole, right? You wouldn't be asking Pikachu like what all the Pokemon that exist in the universe are. It just belongs to the Pokemon class as a whole. So you'd have something like Pokedex equals and have like an array, which would store like Pokemon names. So yeah, any Pokemon names that you want to add to the Pokedex? I'll just
Anyone have any
add a bunch
examples of Pokemon names?
Squirrel.
I like Ditto.
Charizard.
Yeah. I don't know if I spelled that right. All right.
Fairy.
Yeah, I think that's. But where was it?
Clefairy is my favorite.
Oh, Clefairy. I don't know how to spell that.
Yeah, and Jung said Snorlax too. I think that's
Oh
right.
yeah, I love Snorlax.
I love Snorlax.
Okay, so
Snorlax is my favorite
I can't
Pokemon.
be sleeping on Snorlax.
No,
Yeah.
Snorlax
Imagine we're creating
sleeps
like
on you.
Alright, somebody got it.
so imagine we're creating like a new Pokemon game, and these are the Pokemon that would exist in the universe. And it's a class variable because it would belong to Pokemon class as a whole. And we would need to we need a way to print it out. So we can call this class variable using a class method and then print out the Pokedex. So with
When you
class
guys
methods, you
decide-
want to pass in the class itself as a parameter. Yeah, go ahead.
I was gonna say, when you guys are deciding when to use class variables and class methods, you really have to ask yourself, is this something that should belong to only one instance of this class? Or is this something that should be existing like exactly the same throughout all instances of the class? Or like an
Yeah.
action that all instances of the class shouldn't be able to do like uniquely? Or like something that belongs to the class as a whole and not really an individual instance. I don't know if that was convoluted or not, that explanation.
You're saying the class method is kind of like the class variables, as in you would call it class method if it pertained to class as a whole, not just the individual instances.
Yeah.
Is that correct? Okay.
It basically means when you're trying to perform an operation or like store information that's relevant to every single instance of the class, every single object of that class. For example, like check if fainted, it doesn't really make sense to check if every single Pokemon is fainted at once, right? Something like that.
Unless someone used explosion.
That too.
Yeah, so this class method, print Pokedex, will print out all of the class or all of the Pokemon that we define in the Pokedex array. So yeah, just we're gonna just loop through this array and then print it out. So so this is how you call class variables inside a class method. So you can see here, you're passing in the class as a parameter inside of the class method. And then in order to call the class variable Pokedex right here, you would need to do cls.pokedex. And this is just like self, but for classes. And then we'll just print the Pokemon. You don't need to do any cool formatting because these are strings. Okay, so yeah, I think let's just quickly check if that works. All right, so notice that we're calling the class method on top of the class method or class name as a whole. We're not actually calling it from an instance. Does that make sense? So opening up the terminal here. All right. Okay, so we're gonna run Pokemon. Okay, so as you can see, it printed out all the Pokemon in the Pokedex, so it looks like our class method is working. Okay. So, all right. Part 2, we're gonna define a Pokemon trainer class. So trainers are people who actually have Pokemon and battle other trainers with their Pokemon. So yeah, let's define a Pokemon trainer class. Think of the instance variables / nouns this class will have. What should the init method look like?
Oh, what do you guys think? Oh, we're gonna put in the init method for the Pokemon trainer.
You can give him a name and then like what Pokemon he has.
Yeah. Those are 2 good ones.
Yep. Actually, those are the only ones we need because we want it to be really basic in the first round that we're doing it. So
Can anyone think of any other examples that we could include though?
yeah.
Include what was the question?
As
Would,
our instance variables or our properties.
Okay.
Yeah, Kyle, I think we technically could include gender. I think.
Would a Pokemon, whatchamacallit,
I mean, I think
gym leader inherit from a Pokemon trainer?
Yes, exactly. Yeah, that would
Okay.
be.
That's a really good example, Steven.
We can actually do that if we have time at the end.
Yeah, if we have time, we can make a gym leader child class and you do stuff like
well, now that I think about it, like, yeah, I think gender could probably end up being an instance of the Pokemon trainer,
yeah, because traditionally in the games, I think you get to pick your, I'm not sure if you get to pick your gender or not in the games.
You can now.
Yeah, so in Pokemon trainer class, or every instance of the Pokemon trainer is gonna have an array, and that would be its Pokemon party, and that's where all of the Pokemon objects will be stored.
Yeah, if you want to make this a bit more complex and like stay true to the games, you could cap the array size at 6, but like for now, we're just gonna only worry about having 1 Pokemon because that make it a little bit too complicated for us to get into right now.
Actually, we can do that now. It doesn't take that long.
You think
So
so?
we can create like an add Pokemon method, which would just add a Pokemon to the current Pokemon trainer's party. So we can check the length of the Pokemon and see if it's greater than 6, and if it's greater than 6, we can't add. But then otherwise, we're gonna add it to the Pokemon's array. So. If the length of your current Pokemon party is greater than 6, we're gonna print not add and then return because we don't want the rest of the adding part to be executed. And then after that, we're gonna actually execute the adding part. So to add to an array, you need to append. And then we would append the Pokemon to add, which would be passed as a parameter to the add Pokemon method. Yeah, and then part C, create a battle, self, comma, other trainer method. This will cause the trainer's Pokemon to attack the other trainer's Pokemon. I'll keep it simple, only Ash attacks Brock. So yeah, we're gonna create a battle method, and this will be the functionality that would cause the Pokemon objects that are stored in the Pokemon party array. It will cause those Pokemon to attack each other. So let's see. Okay. So since we're keeping this simple and we only have one Pokemon object per trainer, one Pokemon per trainer. So how would you get like the first Pokemon inside of this array?
Anyone have any ideas?
Could you repeat the question one more time? I'm sorry.
Yeah, so each trainer, Pokemon trainer, will only have one Pokemon because we're only going to be adding one for simplicity's sake. So how would you get the first Pokemon inside of the party?
By the index, right?
Yep, exactly. So because there's only one, we're just gonna zero index it. And then say like my Pokemon equals this, because this is calling from the self, and then faux Pokemon would be called from the other trainer's Pokemon's party instance variable, which is an array, and then we're gonna again index it by 0.
You not have to call self in that instance either for the faux.
The reason why we don't call self is because you're passing in the other trainer, Pokemon trainer object as a parameter. So we're just calling Pokemons off of that instead of calling out of self.
Yeah.
Self
Like
just refers to the current trainer that you're on, that you're referring to.
So like, let's say you say like Ash dot battle, right? Self is refers to Ash. Does that make sense? If we did Brock dot battle, then self would refer to Brock. To get the other trainer, we have to look into those parameters, because we would do Ash dot battle parentheses Brock inside of that, right? So the other trainer becomes equal to Brock. So we can do Brock dot Pokemon sub-0 instead of to get our faux Pokemon.
Okay, so basically other trainers almost equivalent of like self in this case when you're referring to yourself essentially.
Yeah, they can be used in the same way, but they're referring to two different instances of the trainer class.
Oh, okay, yeah, that makes sense. I wasn't 100% sure on like the nesting on getting access to the photo.
In terms of how you would use them, they do the exact same thing, but obviously the Pokemon arrays, the Pokemon array in like self is going to be different from the Pokemon array in other trainer, because they're referring to two different instances of the class. So they're gonna have different instance variables.
Yeah, when you explain like that, it makes a lot more sense.
Got it. Anyone else have any questions so far? No? Okay, I guess we can keep going then.
All right, let's keep going. So yeah, when one Pokemon trainer is battling another, we first need to check if the Pokemon are fainted or not, because otherwise what would be the point in battling if they're fainted, right? So we can just use this check if fainted method that we implemented before and check if the Pokemon are fainted, and if they are, don't go through with the battle. So if my Pokemon check, if what was the name? Check if fainted. Yeah, so the reason we can call this method inside of the Pokemon trainer class is because my Pokemon is actually a Pokemon object. Yeah, so if it's fainted, then your Pokemon other. If the other Pokemon foe is fainted, then you're gonna print. And then we're just gonna add like a return statement to each block because we don't want the rest of the battle logic to execute since the Pokemon are fainted and cannot continue with the battle. Okay. And then we're actually gonna have the logic for the Pokemon to battle. And if we scroll up to the Pokemon class, you can see that we already implemented the attack logic. So all we have to do is just call the attack method, and that will just reduce the health for us. So we're gonna get my Pokemon to attack the full Pokemon by calling the attack method. And then after attacking, we're gonna check again. We're gonna check if the foe Pokemon is fainted. And then that would determine whether you have defeated the opponent or whether you have more attacking to do. So if foe Pokemon fainted, if the foe Pokemon fainted, print, you're gonna print you have defeated the opponent. Otherwise, if it's not fainted, you're gonna print. Yeah. All right, so any questions so far?
So how would you write up the logic? I'm assuming this isn't one-sided, so how would you write up the logic for terms if it makes any sense?
Yeah, so you probably do full Pokemon that attack my Pokemon, right? But for simplicity's sake, we're gonna make it one-sided for now, and then if we have time, we can implement the foe Pokemon retaliating back with their attack. Did that answer your question?
Yeah, it does.
Okay, so, all right. I think that's, yeah, we did part C. So that's all the basic functionality we need in these two classes. So let's actually try it out and see if it works. And so we already tried printing out the Pokedex, that works. Below that, we're gonna instantiate the Ash and Brock trainer objects. Okay, so you can set a new variable Ash and set that to a Pokemon trainer. And then in it, what would you need to pass in as a parameter inside Pokemon trainer, given what we have here in the init method?
Trainer's name and then their, in this case, is their single Pokemon.
Wait, what was the second part?
Their single Pokemon in this case.
Well, if you look at the init method, what are the two parameters inside that init method that we have right now?
Pokemon trainer?
Yeah, in Pokemon trainer.
Oh, I didn't see that. It's just the name. My fault.
It's just the
I
name,
thought-
right?
Yeah, I didn't see the same part.
So if you look down line 38, we actually add the Pokemon in a separate method, right? We don't actually use the init or the initialization to add the Pokemon.
Yeah, I just
If you want
assumed that.
to-
Oh, sorry.
Yeah, if you wanted to, you could like pass in a Pokemon party like as a parameter when you're actually creating the Pokemon trainer, but it doesn't really make sense to do that because when a trainer is first starting out, they don't start off with Pokemon already in their party. You have to add them. So that's why we use like a separate method for that. But you could like do it your way too.
You
Okay,
guys,
so
oh, sorry. Maybe you guys already answered this, but the arrow and the none after the init, is that because you're not passing? I'm sorry, I'm confused on that part.
the arrow is just the return type, like what this method will return. So if we had like return, like if the init method were to return something, you would just change this type to whatever you're gonna return. But usually the init method doesn't return anything. It usually returns none, so that's why we have the arrow none. And this is optional. It's just for other developers to know, like what the method will return, what the type of the method.
Just kind of a comment more than anything.
Yeah,
Very
that's a way to think of it.
Yeah, but yeah, this is just optional. Okay. Yeah, so you just need the name. So we're gonna pass in Ash as the name, and then we're gonna instantiate the Brock object too. And then create one Pokemon for each trainer, add one to Ash's party and add one to Brock's party. So Ash's favorite Pokemon is Pikachu. So we're gonna instantiate a Pokemon object using the init method. And as you can see, there are 3 parameters here: name, health, and damage. So we'll need to pass in those values when we're creating the Pokemon object in order: name, health, and damage. So name would be Pikachu. Health, let's just
I have
make
like a weird question about you passing that in.
Yeah, sure.
Would you be able to put in almost a logic check to make sure that, like, say for name, they're not putting in a number, and then for like health, they're actually putting in, say, an integer versus a float or stuff like that? And if you could, would you do that in the init method, or would you just put that somewhere else?
Oh,
yeah,
if you're
so
gonna error check inputs. Oh, sorry, Juan, you can answer that.
yeah, there's a way to do that actually. If you didn't know like which one came first, but you knew what the parameters were, you can actually do health and set that equal to 5, like actually have the health there too. Like normally you would just have Pikachu comma 5 comma 10 or something, but you can actually specify the variable that you want to assign and then pass in those values like that. Yes.
Yeah, but also like if you were to design this like yourself and you're like obviously giving this program to someone else and you have no guarantee that they'll use it correctly, like how you programmed it for, a lot of times, usually the first thing you want to do after initializing a method or a function is usually to error check the inputs or to check the invariants to make sure that nobody like invalidates the like basically requirements of the parameters. Like for example, in this case, health should be a non-negative positive number, right? If someone put in -50 for health, like yes, the program would still work, but it's not going to work as intended because this wasn't designed to work with health being a negative number. But technically, your code would still compile, your code would still run if you put in -50. So in this case, that's where it's good to like, in this case, it's like the professional term is we call it like checking invariance. It's going to be checking to make sure all your requires are basically met on all your parameters. Did I answer your question, Alexander?
Yeah. What did you call it again? Checking what?
Check invariance. It's a technical term. It doesn't really matter. You guys don't need to know the term. It's not really important. What is important is I generally do think it's good practice to always check to make sure your inputs are correct. So for example, in this case, name should be a string, health should be, a positive non-negative number. Same with damage, right? Those are the 3 things you want to check for to make sure that whoever's using your code is using it correctly. And if you were going to go to attack, you want to make sure that faux Pokemon is a Pokemon and that faux Pokemon is not yourself, right? Those are the 2 things you want to check for in attack, stuff like that. Obviously in this case, it's not really necessary because we're the ones designing it, but in the real world, it is 100% necessary to include that in all of your functions.
Yeah, I wasn't trying to make y'all code more complex. I know you're trying to keep it simple. I was just trying to think in the future.
That's a very good question because it's super important and it's super relevant as well to like all of you guys. Yeah, so I see Juan's including that right there. Yeah, helps be positive.
Yeah, and then return.
Yeah. If we were to actually like design the Pokemon game or something like that, then we would include something like that. But since it's just an example for you guys, we're just gonna skip over it for now. But that doesn't mean it's not important. It's still super important.
Another approach, health is negative, just set it to 0 and go on.
Like that you could do that, but I feel like it would be better to give feedback to the user, like, hey, I don't know if this is on purpose or not, but you entered, maybe they meant to type in 50, but they accidentally typed in -50, right? I would rather give the user the chance to re-input a correct input than just set it to 0.
Yeah, it depends on circumstance.
Sorry, Don, I didn't guess that.
It depends on circumstances.
Yeah, it does. It really does. But either solution technically is like a viable solution.
Yep. Yeah, so yeah, back to the problem. We create a Pikachu, which will add to the Ash Pokemon Trainer object, and we'll create a new Pokemon for Brock. And anyone wanna give a Pokemon to Brock? All right, let's just do like a Psyduck or something. And then name, health, and damage. So let's put those in order this time. Instead of doing what we did above. Health would be set to 5. Damage set to 4. Okay, so we've created all of these objects, but we haven't actually added Pikachu to Ash's party, and we haven't added Psyduck to Brock's party. So let's go ahead and do that. Oh yeah, we created a method, add Pokemon, which will add the Pokemon to the party using the append method. So Ash will get the Pikachu. Brock will get the. All right. And then, yeah, tell Ash to battle Brock, see who comes out on top, the trainer who has the non-fainted Pokemon names. Okay, so let's call the battle function, which does what this wants it to do. So Ash battle. All right. And then because in our battle, we implemented like, you know, if we have defeated the opponent, it's going to print it. So we don't need to have additional logic in here to know like who came out on top. It's inside of the battle function itself. So all we need to do is call it, and then we'll have the result of the battle. And let's see who wins. Okay, so you have defeated the opponent. Looks like Ash v Brock. And as you can see here, Pikachu has a damage of 5, and Psyduck has a health of 5. So 5 minus 5 is 0. And so Pikachu or Psyduck fainted. But if we set Psyduck's health to something greater, then it would say haven't defeated the opponent yet, because 6 minus 5 is 1, which is still positive. Does that make sense?
So in this case, if you wanted to defeat Psyduck, would you have to call Ash battle Brock twice, or would you just keep working in the console and then eventually look at you have defeated the opponent?
You have to call it twice, because when you call it once, well, every time you call it in the command line, it's just going top to bottom, and it's recreating Ash, recreating Brock, recreating these Pokemon, and so they'll still have the same health values. So it'll always be haven't defeated opponent.
So it wouldn't be persistent, basically.
It'll be what?
So it wouldn't be persistent, basically, because all you're doing is just
Right.
starting again from the top.
Yeah, but you could like store health values in like a CSV or something. I know you guys love CSVs, but yeah. So we call it twice here, right? We attack twice, so it's basically 5 times 2 now. So it's 10 damage. So 6 minus 10 is negative. So it says you have defeated the opponent. All right. That's the end of the problem. We could like have an inheritance thing if you wanted to. You guys want to see that or no?
Is there anything particular you guys want us to like add or anything like that?
Yeah. What functionality do you want us to add?
Yeah, do you want us to see?
If there are any.
And also if you guys have any questions too.
Yeah.
No, I guess no questions.
I must say, I think overall, like it makes sense when you're walking through it. There's nothing saying that I retained all this as soon as I go to try to do it myself.
Yeah.
Yeah, I mean, I think I'll mirror what Alexander just said, which was like, I mean, when you break it down like this, now it's like making sense and stuff. You know, I guess kind of had to tell us in a language we understand, but obviously gotta, maybe have some more repetition at it. But this breaking it down like this, I'm like, okay, now as opposed to just trying to Google everything and make it work. Now this makes a lot more sense.
Yeah, generally when trying to approach an object-oriented programming, like a problem or question, first gonna start off by trying to see like what kind of like categories you want to categorize your solution by to figure out your classes. And then once you have your classes, you want to look for like what verbs, what actions do I need each object to be able to do. And let's say, like, for example, if you're making, go back to the Pac-Man example from before, right? Pac-Man, if Pac-Man's our class, what are some actions that he needs to do? One, he moves around, right? That's like a big one. So we're going to need to have a function or a method that describes the movement, right? And the control of the movement. And what else does it do? He eats, the dots. That's another method because that's an action, right? Eating is our method. He's yellow, but that's more of an instance, right? That's a property. He is yellow. So that's going to be like an instance variable in that case. So if you think about it in those terms, it usually makes it really easy to construct your classes. And then once you have an idea of what those classes look like, then it makes it a lot easier to go out and just code it out. I hope that helps.
So basically you're saying spend more time planning out your blueprint / classes before trying to do it bit by bit and figuring out, oh, you need this.
Yeah, with OOP, it's super important to be like planning your approach because it's a lot more open-ended than simply like writing an algorithm to solve something.
Yep. And when we get to SQL, you'll see that like creating in SQL, you create like different tables, and you'll see that like these tables are pretty similar to classes, and these tables will have like something similar to instance variables. So that planning will come in handy when we're designing SQL tables as well.
Yeah. The most important part is just plan it out, and if your plan makes sense, then your solution will probably make sense as well.
Yeah. I remember Steven mentioning a gym leader inheriting from Pokemon trainer. We can quickly do that right now. So if you want to inherit, you want to put the class that you want to inherit from inside of the parameter. So in this case, it's Pokemon trainer that we want to inherit from. And so when we do inheritance, like all of these methods that we defined in the Pokemon trainer class, those are there in here. So you can call like
automatically gets those basically.
Yeah. So when you create like a gym leader instance, you can do that gym leader battle, it'll still work. And let's define an init method for this gym leader. Ooh, it's a bit complicated. All right. So yeah, we want to pass in a name again, and then we can also have like a type of gym that this gym leader leads.
Oh, I want to say one thing, actually, before you keep going. The use of super here, in case like for you guys who like don't really get that. So if you scroll up, you see self, like right here. So what super does, it's going to find the super class or the parent class of gym leader, because gym leader is a child class. So basically what super does, it's going to go up one and find the exact same line. So that's going to be the init from the class above it. So it'll call that init, it sees, oh, self.name equals name, self.pokemons equals blank, right? So it's going to basically already initialize those without actually having to rewrite the code. That's what your super call is doing in this case.
Yeah, that's why inheritance is so important in dry, don't repeat yourself.
Yeah, because like if it wasn't like, if we didn't have that super thing, that super line right there, we'd have to rewrite that whole init function, right? Which is fine because it's only a small function, but like when you get into more complex stuff and your init functions, because you have let's say you have like a really complicated class, or you're actually initializing Pokemon, right? And your gym leader and your trainer class has like 20 attributes, and your constructor class is like 200 lines long. You probably don't want to rewrite that, right? So in one line, you basically copy the entire thing. So it helps you organize your code a lot more as well.
Yeah, exactly. Yeah, so just to reiterate, when you're calling super, you're calling the init method of Pokemon trainer. So you're going here and then assigning name. But then we also have type that we want to pass into gym leader. And then because Pokemon Trainer, it doesn't have the type instance variable, we'll just create one inside gym leader and set that self.type equals type. And yeah, this gym leader will have whatever type you want to pass in.
Yeah, so in this case, every instance of gym leader will have a type, but not every instance of Pokemon trainer will have a type, right? Does that make sense? Because all gym leaders are Pokemon trainers, but not all Pokemon trainers are gym leaders.
Got it.
Does everyone get that?
Yeah, that makes sense.
It's like the whole square quadrilateral thing, right? Like all squares are quadrilaterals, but not all quadrilaterals are squares.
So right here, we are creating a new gym leader instance. And unlike the Pokemon trainer, which has one parameter, we're going to have two parameters for gym leader because we have an additional type instance variable that we want to pass in as a parameter. So yeah, if we print that, you can see that it's what we expect it to be.
Also,
we're going
for
to print
example,
its type and it's
For
water.
example, if we try to print the type of, let's say, Ash or Brock, it wouldn't work in this case. Ash and Brock are just regular Pokemon trainers, and they don't have that type attribute as a gym leader. Well, technically, Brock is a gym leader, so maybe we should make him a gym leader, but that's
Yeah, that's true.
Yeah.
All right. I
Does
think
anyone
that's
have any
all.
ideas? Wait, sorry, Juan, what are you gonna say?
No, I was just gonna.
Does anyone have any ideas for like a method that we would put in the gym leader class?
Probably like is defeated, because then that's when you usually get their badge.
Yeah, that's exactly what I was thinking. Like maybe like give badge or defeated or something like that.
It was just make it simple like that.
I mean, you can say here's the self.type badge. You know what I mean?
Oh yeah.
That's what I was
We're calling this instance variable
Yeah.
of the current gym leader, which is pretty cool.
You're not the
Yeah, here's the.
Now it'll give you whatever type the gym leader is. So now if we do Misty.get badge, that should return here's the water badge. Yeah. Hey, do you guys feel like you understand classes and like class functions, class variables, instance variables, all that stuff better now?
Yeah.
I see Jonas nodding his head.
So I have a question.
Yeah, sure. What's up?
So this is kind of going in the weeds with it, but I was just trying to think of the logic. So with the get badge method, would you almost incorporate that almost in the battle, like after checking the function, like is the Pokemon defeated, would you also include that method get badge underneath it once the Pokemon's defeated for that leader or whatever, or how would you implement that?
In this case, I would probably just implement that outside of the class. You could implement it inside of the class, like that you only like you're only gonna get the badge after all of our Pokemons are fainted, right? It'll like check that first. But
you could do it inside too, like this.
Yeah.
Have you just checking the first Pokemon of the gym leader, and if that Pokemon's fainted, then you're gonna get the badge. Otherwise, you won't get the badge.
Yeah. But generally, since I think the actual specifics of battling occur outside the classes themselves, right? Like we have that battle method inside the class, but we're actually calling it outside the class, correct? So since the actual battles are technically happening outside the class, I personally would check if like the gym leader is defeated outside of the class, but that's not necessarily the be all end all. That's not how you have to do it or necessarily how you should do it. Because either way works. Generally, the benefit to putting stuff inside a class is it saves you on repeat code, so you don't have to retype code, makes it easier to debug, makes your code more readable. But at the same time, you have to make your code more general. Your code has to be able to apply to every single instance of that class, right? We can't like let's say we have like an edge case, right, where I want just Ash right? To lose this battle, right? I can't code that into the class itself because that's going to affect every single trainer. In that case, since I'm worried about one instance in particular, I would make those changes outside the class and write my program outside the class tailored to that one specific instance. Versus, let's say I want all trainers to have a difficult time battling gym leaders, then I would code that into the class itself.
Okay, yeah, it makes more sense. You kind of want to essentially make some classes like the Pokemon and then the trainer one more general, and then like the gym leader you want it more specific because gym leader is a type of trainer, and that's getting the badge is only going to occur with the gym leader.
Exactly. Yeah. Does anyone else have any questions? Anything, guys? No? Okay.
If not, we'll just close it off here.
Yep, I'm gonna end the recording.